This video is going to look at the bonding and structure questions, the longer questions, question 2, and as usual, really have a go at the question before you look at the answers. So, we've been given the formulae of two ions, CH3- and CH3+, and we're told they're intermediates, so they're not normal ions, and the first thing we need to do is to form an electron, dot and cross diagram. So the first thing to think of is that these ions, it says, are formed during certain organic reactions. So there is no thing that has the formula CH3, because if you drew something that had the formula CH3, it would have an odd number of electrons. It would be a radical. And so you wouldn't have a radical that would just like gain or lose an electron. Radicals would just form bonds with something else. So what that means is that these two things must have formed from something normal that we know about, such as CH4. So the most likely origin is CH4. To make CH3- from CH4, I would have to lose a positive hydrogen ion, and that would leave behind a CH3-. So when I do the dot and cross diagram, I can basically just start drawing methane like I normally would. So I'm only going to put in 3 of the hydrogens, but I've left behind an electron from a hydrogen atom that would have been there, but I've removed it, which means I'm just removing the hydrogen ion, H+, by leaving that negative charge behind. So if we look at the carbon and say, for example, that the carbon is crosses in this diagram, we can see there are 4 crosses. Each hydrogen provides 1 dot, so each of those has got some, and we can see therefore there's an extra electron. Doesn't belong to the carbons or hydrogens that we can see, and that's why it has a negative charge. Some people like to show that electron as being somewhat different. That's absolutely fine. You don't have to though, it's perfectly fine to do a dot and a cross. What we don't want is like 2 crosses because they didn't both come from the carbon. So what you can do is you can rub out the dot and make it something like an open circle. That's a good way of showing an extra electron that came from somewhere else. As I said though, that isn't actually necessary. What is necessary is this is an ion, so we put square brackets and we do the charge on the outside. Okay, that's CH3- and CH3+, slightly easier. CH3+ simply means wouldn't really form from CH4. So where CH3+, you may have seen this reaction before, is where a bond breaks unevenly. So for example, if you had chloromethane and the carbon-chlorine bond breaks, so you have done reactions where that breaks with sunlight and it actually breaks as a free radical. But if it was breaking in a substitution reaction, for example, then the chlorine's more electronegative, so it would pull the electrons towards it and leave behind a positive carbon. So that's the most likely mechanism for forming a positive carbon atom. And so it's basically now we're drawing methane, but we're only drawing 3 of the hydrogens and we are taking away the electron that belonged to the carbon. So again, if carbon is represented by crosses for its electrons, you can see that it only has 3 crosses and that there's a space there where the chlorine has taken away the electrons and become Cl-. As before, we would need to actually put our charge in. On the right hand side you can see the curly arrow idea, so you can get the idea of how that would fit in with an organic mechanism, because this question could get put into an organic mechanism question. Charge on the outside of the brackets. Altogether, drawing those would be worth about 3 marks, most likely. Okay, so it'd be marks for the correct bonds, marks for the extra electrons on the minus, and marks for the charges that you have as well. The next bit's predicting the bond angle and predicting the shape and explaining the difference in the shape and the bond angles. This is all very standard shaped stuff, so we're going to look at actually how we could just answer it for both of them separately using our valence shell electron pair repulsion. So we're just going to be using a description. We will start with CH3 minus and then compare with CH3 plus. So we're always going to start with talking about the areas of electron density, or just areas of electrons, areas of negative charge. It has 4 areas of negative charge. And within that, obviously, areas of negative charge will repel and move as far apart as possible. So watch out for saying repel as much as possible. That's not something that electrons have any say in, because they're just repelling according to the laws of physics. Be careful, so don't say that they repel as far apart as possible. Again, they move as far apart as possible because they repel each other. I've tried to keep the wording as short as possible while still retaining the meaning. And we need to consider what the 4 areas of electrons are. So we've got 3 bonds and 1 lone pair. And we certainly might want to talk about the fact that a lone pair has a higher repulsion, or repels more, than the bonding pairs. And so by doing all of this, we are explaining the difference in shape. So we're not looking for anything off script. We're just using our usual explanation of why it has that shape. And so the bond angle would be 107, 109.5, take away 2.5, and it's a pyramidal shape. It may be that your exam board does not actually talk about the reduction in bond angles due to the lone pairs. So just bear that in mind. Some of will just keep the 109 if it's 4 regions of electrons, and they will simplify it. And actually there's nothing wrong with that, because all of these are simply predictions of bond angles. The actual atoms involved can make a difference to the final angles. But pyramidal is definitely the shape, because the 3 hydrogens are going to point downwards. So there'd be a mark for the angle, a mark for the shape, and then there'd probably be at least another 2 marks now. So we're up to 7 marks. We're going to now just get the other 3 marks for doing the same thing for CH3+. So it'll be a mark for the angle, a mark for the shape, just 1 mark for the explanation, because we've pretty much already said all of these explanation points in the previous bit. But we start from scratch again, 3 areas of electrons. And there's nothing wrong with writing this out again. So the fact that they repel and they move as far apart as possible, writing it multiple times helps us practice saying it, especially when we're doing practice questions. If we were running out of time in an exam, we wouldn't repeat ourselves, because we've already explained that point. We're not going to get a second mark for it. But we should point out that there are no lone pairs, so everything is a bond. And that means that our 3 areas of electrons will be 120 degrees apart, and the shape will be trigonal planar. It is kind of important to get that word planar in, because remember that you can have a much less common shape, which is trigonal bipyramidal, where you have another 2 areas of electrons above and below that shape. And so 120 degrees would get you another mark, trigonal planar would get you another mark, and then the final mark out of the 10 would just be for saying about the 3 areas of electrons and no lone pairs, so linking it to that molecule.